Hello friends, in this video we are going to see the optimization technique and linear programming problem method, the simplex method of solving the linear programming problems. Okay, how to solve using simplex method. This will comes under operation research, operation technique subjects. Okay, now go for the problem. Solve the LP, that means linear programming problem using simplex method. This is maximize kind of function. Maximize z is equal 10x1 plus x2 plus 20x3, that means 15x2. Subjects to constraints 2x1 plus 4x2 plus 6x3 less than or equal to 24, and 3x1 plus 9x2 plus 6x3 less than or equal to 30. Both x1, not both, x1, x2 and x3, all three variables are positive values, non-negative values greater than or equal to 0. Okay, in this problem, two constraints, one objective function, but three variables x1, x2, x3 is there. You may get the problem with two variable also, only with x1 and x2. Okay, now we are going to solve this using simplex method. Before that, you need to know the steps used in solving the simplex method. What means, first thing you are going to do means write the standard form of given linear programming problem and introduce slack variables. Very simple step. Okay, we will do. Before that, you need to know the steps, right? Then second thing, you write the canonical form of the linear programming problem. In canonical form means it is the form in which each constraint has a basic variable. This canonical form is generally used to prepare initial simplex table. Okay, then we are going to construct the initial simplex table. First we will do these three steps in our problem. Okay, let's go to the solution. How to write the standard form means maximize. What it is given? Maximize. Write the objective function as it given, 10x1 plus 15x2 plus 20x3. Subjects 2. Okay, 2x1 plus 4x2 plus 6x3. Here in this constraint plus s1, this is slack variable. This is called slack variable. Instead of less than or equal to, put equal to 24. Okay, this is the standard form. Similarly, the second constraint, 3x1 plus 9x2 plus 6x3 plus, in this case, s2 is the slack variable, equal to 30. What it comes? x1, x2, x3, in fact s1 and s2, all these variables are non-negative. Okay, this is the standard form, and the slack variables are introduced in the constraints. This is our first step. From this form we are going to write the canonical form. Very simple form. Okay, canonical form. Just repeat, maximize z is equal to 10x1 plus 15x2 plus 20x3, and bring the slack variables to objective functions. Slack variables is not having the value, so 0 s1 plus 0 s2, it is not having any specific value. Just introduce the slack variables, include the slack variable to objective function with the value 0, and rewrite the constraint equations here. This is canonical form. Very simple step. Subjects to 2x1 plus 4x2 plus 6x3 plus s1 equal to 24, 3x1 plus 9x2 plus 6x3 plus s2 equal to 30. You need to write all these things again and again. s1 and s2 is non-negative value. Okay, this is the canonical form and that is the standard form. Okay, using this canonical form we are going to construct the initial simplex table. Okay, let's see what is the simplex table, how it will be. This is the simplex table and what are all the values will come, that I will tell you. 1 2 3 4 5 columns and 1 2 3 rows. In this, second column and third column will be divided into 2 rows. Okay, will be divided into 2 rows and here you need some space for solution. Okay, what are all the things will come in the sense, here it is CBI. Okay, here it is CBI. That means the coefficient of the ith variable. This is the coefficient of the ith variable. Cj is the coefficient of the jth variable to introduce here. Cj. Here Cj. Here basic variable. Right. Then here solution. Here ratio. And here ratio. And just a second, and here zj values to be calculated, and finally cj minus zj. Cj is here na, cj minus zj. Okay, just we will calculate what are all the things. From the canonical form we are going to fill this table. Okay, where is the canonical form? Here it is, the canonical form. Okay, what to write in the place of Cj means this values, these coefficients 10, 15, 20, 0, 0. Okay, 10, 15, 20, 0, 0. Right. Okay, what are all the basic variables means the variables x1, x2, x3, s1, s2. Okay, here only 2 rows will come. Why 2 rows means we are having only 2 constraints. These 2 rows will come here, but instead of basic variable initially put the slack variables s1, s2. Right. Now this value 2, 4, 6, then s1, then 24. Okay, how to fill means 2x1, 4x2, 6x3. Instead of s1 in this constraint you are having the s1, so put n, but you are not having s2, so put 0 here. Okay, right. Similarly in the second s2, 3, see 3, 9, 6, s2, 3, 9, 6, no s1, so 0. When s2 is there, put 1. In solution column, what is that? Equal to 24, here equal to 30. This is equal to 24, is equal to 30. Right. Now we are what will come in the place of CBI means, for the initial table it is 0. For the initial table it is 0. Okay, zj, how to calculate zj means zj is nothing but 0 into 2 plus 0 into 3. That means CBI into this coefficient a into 0 plus 0 into 3, summation. Okay, we will do in the next table the clear calculation we will do. Initially put all the zj values into 0, just default, it will come. Right, including solution column, and all the variables column. Okay, Now Cj minus Zj, 10 minus 0, 10, 15 minus 0, 15, 20 minus 0, 20, 0 minus 0, 0, 0. Okay, what is this means? This is initial simplex table. What is this? This is initial simplex table. This problem is little time consuming, but if you understood, we can solve it easily. Okay, now our problem starts. Okay, after constructing the initial simplex table, what are the steps means? Finding the key column, key row, key element from the initial table which corresponds to the entering variable, this step, and check for the optimality condition. Whether the optimality condition, how to check means, for maximization problem, when all values of Cj minus Zj are less than or equal to 0, either negative or equal to 0, means the optimality reached. If it is a minimized problem, when all the Cj minus Zj values are greater than or equal to 0, then the optimality condition reached. If not reached, then optimality condition not reached means we will go for iterations. Okay, for maximization problem, select the maximum Cj minus Zj value as the entering variable. If it is a minimization problem, the most negative value as the entering variable. Then we need to calculate the new values and form the new table called iterations. New initial simplex table. New simplex tables called iterations. Okay, mostly it will take 2 iterations for each problem to reach the optimality solutions. Right? Let's see how to do this. What we need to do means to find the key column, key row, and the entering variable. Okay, if this is a maximization type problem, this is maximization type problem. How to find the entering variable? How to find the entering variable means the maximum value of Cj minus Zj, 20, see 10, 15, 20, 0, 0. Select the maximum value of Cj minus Zj as the entering variable and put a star here. Put a star here. Okay, this is the entering, which is entering variable means x3. The value, the basic variable in straight to this maximum value is x3. This is the entering variable. Okay, now what we are going to do means, this is the key column. This is called key column. We are going to find the key row, key column after finding the key element, right? This is the key column. Just make a box. This is key column. Just make a box. Okay, you got the key column values. Now find the ratio. In 24, what is the key column value? 6. 24 by 6 is equal to 4. Here 30 and 6. 30 by 6, which is equal to 5. Okay, why we need to calculate this ratio now means, now we are going to find the minimum ratio. To find the key row, which ratio is minimum, that row is the key row. In 4 and 5, which is minimum? 4. Put double star here to denote that this is the key row. Okay, this is the key row. This is the way to find the key row, key column, and key element. Now which is key element means this 6 is the key element. This will come in both the boxes, the intersected box. 6 is the key element. Okay, we found key row. This is the key row, 2, 4, 6, 1, 0, and this is the key element 6. This is the key column. Now the entering variable x3 is there. Now in the next table you just shift this x3 to here in the key row value. Just shift the x3 as the entering variable here, right? Then we need to calculate the new values for the table. Now we started the iteration 1 table. CBI, CJ basic variable, this x1 values, and these values are going to be the new values right now. This will not change until the problem ends. Okay, now what we are going to do means we are going to get the entering variable. What is the entering variable? X3. Just shift the X3 here in place of S1. Why in place of S1? Because this is the key row. Whichever you find the key row, whether this row or this row, in that row you need to shift this basic variable as this variable as the entering variable. Now here this is the key row, entering variable. Similarly, in place of CBI, the coefficient of X3 is 20. You just shift this 20, right? Okay, now what we are going to do means key element is there na, divide the key element with each and every number here. This just means 2 by 6 to get the new values of this place. Divide the each and every number by this key element. Okay, 2 by 6, what will come? 1 by 3. Now 4 by 6, after simplification 2 by 3. 6 by 6, 1. 1 by 6, 0 by 6, 0. 24, including solution also we need to do. 24 by 6, 4. Not a ratio, that we need to calculate fresh. Okay, this is X3. The S2 remains in its place, its coefficient is 0. Okay, there is no change in it. For this values we need to calculate the new value using formula. Okay, up to solution. That formula is this is the formula. What is the new value means? Equal to old value minus key column value into key row value by key value. Okay, what is the use of this formula? To calculate the new values in this place. Okay, from the old table to form the new table, we are going to calculate the new values in this place up to the solution column. So we are using this formula. In this formula, key column value and key value is constant. What is key column value means? Which row we are going to do for new value? This. For this row we already done. For this row the calculation is different. By the key element you are going to divide all the values and you formed the new value, that is separate. For this row which is not having entering variable, you need to calculate the new values by this formula only. Okay. Okay, now come for this place. In this row, which is the key column value? In this row the key column is 6. Key column value is 6, this value. Okay, and what is the key value? This intersected value, that is also 6. So key column value equal to 6, key value equal to 6. The only change is old value and key row value for each and every value. Okay, this two value remains constant for all this calculation. Now we are going to calculate this place. What is the old value? 3 minus key column value 6 into key row value means the value which is above this value. This is the key row na, above this value in the old table. Above this value 2. This is the key row value 2 divided by key value 6. 6 cancel, 3 minus 2 1. So in this place you are going to replace the new value 1. This place will come 1. Okay, now for this 9 minus 6 into key row value is 4. Above the 9 it is 4. 4 divided by 6. 6 cancelled, 9 minus 4 5. The new value is 5 here. Now similarly this middle value 6, old value is 6, key column value 6, key row value just above this value, that is also 6 divided by 6. 6 cancelled, 6 minus 6 again 0. 0. Now 0, old value is 0 minus key column value 6 into what is the key row value? 1. 1 divided by 6. 6 cancelled, 0 minus 1, this is minus 1. This is minus 1. So here the negative value will come. Then finally this one, what will come? 1. What will come in this place? Old value is 1 minus 6 into the key column value is 0, 0 into 6, which is equal to 1. So in this place it will come as 1. For the solution, 30, old value is 30 minus key column value 6 into key value 6, which is the key row value 24. 6 cancel, 30 minus 24 is 6. Okay, so the new solution value is 6. Now the table is completed with the new values. Now there is no use of initial simplex table. Now we are going to calculate the zj value, then cj minus zj. Then if the optimality is not reached, then again calculate the ratio, repeat the process again, find the entering variable, then go for next iteration. Now what is zj? It's a summation of cb and ai. Nothing, very simple. Come here, zj value is 20 into 1 by 3 for first z value, plus, okay, 20 into 0 into 1, that's all. 0 into 1, what will come? 20 by 3. Okay, for the second row everything will be 0 here because of 0. So just what we do, 20 into 1 by 3, 20 into 2 by 3, 20 into 1, 20 into 1 by 6, 20 into 0, 20 into 4. That's all here. Okay, now 20 by 3, 20 into 2 by 3, 40 by 3, 20 into 1, 20. Now 20 by 6, that will come as 10 by 3 into 0, 0. 20 into 4, 80 will come as a solution here. 20 into 4, 80 will come as a solution here. Now go for cj minus zj. 10 minus 20 by 3 is 10 by 3. 15 minus 40 by 3, it will come as 5 by 3. 20 minus 20 is 0. 0 minus 10 by 3 minus 10 by 3. 0 minus 0, 0. Here 0 or negative, that means the optimality reached. Only for the 3 values it reached. For these 2 values it is not reached. Okay, now go for the maximum cj minus zj value to find the entering variable. Here 10 by 3 is the maximum value. So now for the second iteration, x1 is the entering variable, right? Now go for the ratio. Now this is the new key column. This is new key column, right? After finding the key column, go for ratio. 4 divided by 1 by 3. That means 4 into 3, it will come 12. Then 6 divided by 1, 6. Which is the minimum value here? 6. Okay. This is the key row. This is the key row. Now what will come in the second iteration? The entering variable is x1. X will shifted to here. Then each and every value we are going to divide by this key element. Here the key element is 1. This is the intersected area. Key element is 1. Then again we are going to calculate the new values in the place of x3 using the formula. Okay, up to the solution. Okay, now we are going to iteration 2 to reach the optimality condition. Okay, now we are going to do the iteration 2. Okay, the cj, zj, all this value remains in the places 10, 15, 20, 0, 0. Up to solution we done, not the ratio column. Just see if cj minus zj value, if the optimality reached, there is no need of ratio column, no need of key element. Okay, now just go for the entering variable. Which is the entering variable from this table? x1. x1 shifted to this key row places, this key row. Okay, not if the key row is here, just we are going to shift this as the entering variable, x1. The value of x1 is 10, coefficient 10. Now what we are going to do for the new value in case of key row? Divide it with each and every element with key element. 1 by 1, 1, 5 by 1, 5 0 by 1 0 minus 1 by 1 minus 1 1 by 1 1. The solution 6 by 1 6. For x3 the coefficient is 20, that will remain same, but for this values we are going to calculate the new values using the formula. Here what is the entering variable? X1. Key value, the key value is 1. Key element or key value or key element is 1. Key column value, to find the new value using our previous formula, the key column value is 1 by 3 for this x3 row. Okay, the key row value means for 1 by 3 1, for 2 by 3 5, for 1 0, for 1 by 6 minus 1, and for 0 1. So using the same formula, that means the new value is equal to old value minus key row value, key element divided by the key column value into key row value divided by key element. This is the formula. Using the same formula we are going to calculate the values of the x3. Okay, after calculation what the values will come, I will write the values directly, just you make it with your own. So for x3 the values will come as 0 minus 1 1 1 by 2 minus 1 by 3 and the solution 2. Okay, now we are going to calculate the zj. What is the first value of zj? CB 20 into A 0 plus 10 into 1, 0 into 10 10. Similarly for the second one, 20 into minus 1 plus 10 into 5, minus 20 plus 50, it will come as 30. Then 20 into 1, next thing, plus 10 into 0, it will come as 20 into 1 by 2 plus 10 into minus 1, next value is 20 into 1 by 2 plus 10 into minus 1, 2 tens, 10 minus 10 0 0. Then again 20 into minus 1 by 3 divided by 10 into minus 1 by 3 plus 10 into 1, which will come as 10 by 3. Means 10 by 3. Okay, now go for Cj minus Zj value. 10 minus 10 0, 15 minus 30 minus 15, Cj is here, 10 minus 10 0, 15 minus 30 minus 15, 20 minus 20 0, 0 minus 0 0, 0 minus 10 by 3 minus 10 by 3. I forgot to calculate the solution here. 20 into 2 40, 10 into 2 60, both summation will come as 100. Now look, either 0 or negative means the optimality reached. Here the optimality reached, no need of further solution. So we need to write the final solution. Optimality condition. What is the optimality condition? X3 value is 2, x1 value is 6. There is no x2 here, so x2 is equal to 0, and z optimum is this solution 100. That means x1 will be produced by 6 units, x2 0 units, on x3 2 units production. The optimum value of rupees 100 is getting us a profit. This is the meaning of this problem in case of production. Okay, I hope you understood. This may be a time taking problem, but lot of calculations, simple calculations involved. Okay, this is the simplex method to solve the linear programming problem. Hope you like this video, and thank you.